Welcome to Ixxat Connect, Industrial Networks on Demand. Our expert talk today will be about mastering CAN and CAN-FD, design essentials, and best practices. My name's Emilio. I will be your host today, and I would like to welcome next to me Christopher, Industrial Communication Expert at HMS Networks. He has extensive knowledge and experience in the world of CAN networks communication. Within the next minutes, we will give you a detailed insight into the world of CAN networks and in particular discuss how to migrate from a regular CAN network to a CAN-FD network. But first, let's start with some basics. Christopher, tell us, what is CAN-FD and how does it differ from CAN?
Well, first of all, thank you, Emilio, for having me, and thank you everyone out there for watching this video. So CAN-FD was introduced in 2011 and then later specified in 2015. And CAN-FD in comparison to CAN, so the FD means flexible data rate, has a higher payload and a higher data rate. And if we look now into the difference in terms of payload, we have an 8-byte payload in classic CAN and a 64-byte payload in CAN-FD. Now, if we look at the data rate or the difference in the data rate, CAN-FD has a data rate of 8 megabit per second and classic CAN has a data rate of 1 megabit per second. So overall, or in summary, comparing CAN to CAN-FD, we have a higher data rate and a higher data throughput.
What prompted the evolution from CAN to CAN-FD?
So the primary driver actually came through the automotive industry. So if you think of new cars, for example, or modern cars, we have a lot of ECUs, we have a lot of complex subsystems. Think of battery management systems, think of advanced driver assistance, infotainment, or even advanced seating. So with these massage functionality, for example. And all of these process a lot of data, all of these need to communicate and exchange information. And ultimately this led to the demand of exchanging more information, and thus CAN-FD was introduced with a higher data throughput overall.
From your point of view, what are some of the advantages and disadvantages of CAN-FD in comparison to CAN?
So obviously, we mentioned this at the previous question, the higher payload and higher data rate are the main advantage. So if we now make an example, if you're migrating from CAN to CAN-FD, and if we look at the payload, with classic CAN you have 8 bytes of payload, and with CAN-FD you have 64 bytes of payload. So in theory, you could combine up to 8 CAN messages into one CAN-FD message. And if you now think this through, this will enable an overall leaner and a more efficient communication. Another advantage, especially if you're migrating from CAN to CAN-FD, is that CAN-FD nodes and the devices are compatible in classic CAN networks. So let's say you have a normal CAN network and you're thinking about migrating from CAN to CAN-FD, you can just use a CAN-FD component, a CAN-FD node, and put it into your CAN network and then migrate later. However, it is important to note that the CAN protocol and the CAN-FD protocol are not interoperable. So it is not possible to operate CAN and CAN-FD at the same time. A downside to CAN-FD is definitely the bus length. So in practice we are experiencing a lot of trouble here. However, to be honest, this is really specific on or really dependent on your specific topology. Another downside to CAN-FD, I think, is the cost. So if we look at the cost for CAN-FD transceivers, for CAN-FD controllers, we see that these components are more expensive than classic CAN components, and this obviously will lead to a higher cost in your network overall. But the developments in the last couple of years have been really promising that we will see an equal cost for CAN and CAN-FD networks. Another topic for CAN-FD, I think, is the robustness. So as I mentioned, we are comparing now 1 megabit per second of data rate to 8 megabit per second of data rate with CAN-FD. And this means that the bit time is a lot shorter than with CAN. And because of this shorter bit time, the bits are a lot more vulnerable to any electromagnetic noise, to disturbances, to any errors that might occur. And this decreases the robustness of the network overall. And finally, the last point in terms of disadvantages, I think, for me personally, is that CAN and CAN-FD, as I mentioned, are not interoperable.
Let's talk about setting up such a network. What are the 3 most important things to consider when designing a CAN-FD or CAN network?
If you are designing a CAN or CAN-FD networks, there are many variables to consider. So first of all, there are many variables that influence your network stability and your network overall. So just to name a couple of examples, you have the topology, so how your network is physically spread around the factory. And this is now the second point, the environment. So it doesn't necessarily have to be a factory, right? So it can be a factory, it can be a car, it could be test benches, or even a ship, so maritime environment with a lot of salty water that will corrode your cables. So this is another variable to consider in which environment you set your CAN network. Another point here is, for example, the stubs. This relates closely to the topology or just the overall cable quality. But if you were to ask me now the 3 most important things, I think the first one is the node compatibility. So as we just discussed, CAN and CAN-FD are not compatible to each other. So you will have to make sure that in order to run a CAN-FD network, all nodes must be CAN-FD capable. So all nodes must be able to speak CAN-FD. The second one, and we touched this also very shortly, is the bus length. So it is really difficult to name a rule of thumb here, because the Canon Automation, the CIA, so that's the big organization above CAN, they don't specify really a rule of thumb either. Actually, it is from a technical point of view, in theory, CAN-FD and CAN should have similar bus lengths, and we can say that in very clean line topologies without a lot of electromagnetic noise and with good cabling, this is almost true. So in these environments we see a very good performance in terms of the absolute length. But if you are now talking about stubs, so not having a clean line topology, having maybe more a star or a tree topology, this length decreases very fast or very heavily, and here you will have the length issues. And the third one, I believe, is termination and cable quality. So CAN-FD as well as CAN is supposed to be terminated with 120 ohms of resistance at each end of the communication line. And obviously you need to terminate the network in order for it to run. The next one, the cable quality, is also very important, and we recommend to use standard CAN cables also for CAN-FD, so CAN high, CAN low and CAN ground. For short distances, and if you are running longer distances, we even recommend to use shielded cables to minimize any disturbances or interference.
Are there any specific challenges that companies face when migrating from CAN to CAN-FD?
So as we just mentioned, you should ensure that you have proper cabling, termination, and you should update your knowledge on CAN and CAN-FD topologies. As I just mentioned, CAN-FD is vulnerable to these topology issues. And other than that, the nice thing, and that's also one of the benefits about CAN, is that it's pretty similar to CAN. So other than that, there's not really a lot more to to it for the migration from CAN to CANFD, except one topic. This is where we have the most, or we see that our customers or people without extensive expert knowledge have more difficulties because it's a bit complicated, is the implementation for CAN and CANFD controllers. So if we look at the ISO norm, the 11898-1 norm, it specifies three different possibilities or three different ways of implementing a CAN controller. So the first one is for classic CAN, and with this implementation, this respective node is able to receive and transmit classic CAN messages. However, upon receiving a CANFD message, it will just it wouldn't accept it, and it will send an error frame to the network, and this will increase the error counter on the CAN network, and it will ultimately lead to a bus-off scenario. So it will completely shut down the communication. The second implementation is CANFD tolerant. So this means that this respective node is able to send and to transmit and receive classic CAN messages, and upon receiving a CANFD message, it will just ignore it. So everything runs perfect, there's a CANFD message and this node sees it, it wouldn't do anything, doesn't raise an error, basically just ignoring it. And the third one, or the third implementation, is CANFD capable, and this is also what we recommend for new network designs. So with this implementation, this respective node can transmit and receive normal CAN messages as well as CANFD messages. So this is the normal CANFD operation mode, basically. And now if we look at these three different implementations, this kind of opens up the question of CAN to CANFD protocol conversion or protocol translation, where you would need a gateway for it. So let's look at different scenarios. Let's look at a scenario where you have a CANFD network and you need to translate this to a CAN network, or you have CANFD protocol translating to CAN protocol. So depending on the setup, or the CANFD message to be more precise, there will be different implementations. So let's say the CANFD message you're trying to translate to CAN is 8 bytes or smaller. Then it's pretty simple, because you can just put this 8 bytes of payload from the CANFD message and put it into a CAN message, and you can just translate it one-to-one, basically. This is pretty simple, and it gets a bit more complicated for the second aspect, when the CANFD message has a payload that is greater than 8 bytes. So 8 bytes, everything bigger than 8 bytes to 64 bytes. Because as you can imagine, everything greater than 8 bytes will not fit into a normal 8 bytes of CAN. So here you will need to do something which is called demultiplexing. So this means that putting a payload, demultiplexing it into several smaller payloads, and then putting these smaller payloads into single messages. And actually you can do this, or the implementation, the configuration of such a demultiplexing is pretty simple, just using so-called mapping tables. And another point you can also do is actually the other way around, from CAN to CANFD. This we mentioned at the second or first question, I believe, is multiplexing. So now not demultiplexing, but multiplexing several CAN messages into one CANFD message. So let's say you have different CAN messages of 8 bytes of payload. You can multiplex these CAN messages into one CANFD message, and thus have a more efficient communication.
Now, let's focus on some technical scenarios and solutions. Now, imagine for me that you would connect your PC to a CAN bus in order to read CANFD messages. How would you solve this application?
Yeah, I mean, there's many ways to solve this, but overall you will need a CANFD to PC interface. And depending on your PC interface, you have different options. So let's start maybe with the most integrated one, which would be a PCIe or PCI PCIe mini interface. So we, within HMS networks or within Ixxat, we offer obviously PC interfaces for this. These would be the CAN IB cards. Then the next one or the next interface on your PC might be Ethernet. So using TCP/IP or even UDP. And obviously we also offer a gateway or a connectivity option for you here, which is our CANetNet. And then lastly, and this is probably also what most of the people out there use, is the USB interface of their laptop or of their computer. And as the name suggests it, here we also offer our USB to CAN FD. And to maybe add one more thing here, which is specifically nice about our product offering, is that for Windows, for example, we offer one common VCI driver, which supports all of the previously mentioned PC interfaces, which means that once you have integrated this driver once into your application, you can basically seamlessly exchange these different interfaces. So you could write your application with a CAN IB card, and then later you might need a USB to CAN, and then you can just exchange the CAN interface.
All right. What kind of capabilities can be achieved with the use of CAN-FD gateways and bridges in a network?
So when using such a gateway or bridge in your CAN-FD network, depending on your use case, but in general, you can significantly increase your the network functionality, the flexibility, as well as the stability. So let's maybe look at different aspects. So the first one is definitely the galvanic isolation. So using such a bridge and a network, you can galvanically isolate different bus segments from each other. And especially in today's world with electric mobility, with high voltages, this can protect your very valuable assets from a high voltage discharge through the communication lines. And we highly recommend this for any network designed to galvanically isolate your bus segments from each other. The next one is the range extension for CAN, but specifically for CAN-FD. And there are two options here for these bridges and gateways. The first one is using a CAN bridge. So this is a CAN to CAN bridge, and this will actually double your bus length. And the second option is using a CANetNet, which is a CAN to Ethernet, and then again to CAN range extension. And I mean, here it is really dependent on the application, if you're doing real-time stuff or not. But in general, it's just routing a CAN message over an Ethernet network, and then it's unlimited, could be within a building, could be wirelessly to a different continent. So here, the imagination is the limitation of the use cases. And another topic is, or another point is the flexibility of your topology. So using a CAN bridge or a CANetNet, for example, so gateways and CAN gateways and bridges, you can basically achieve or enable any topology, whether it may be a star or a tree topology. Basically anything is possible. Next is the signal quality. So these gateways and bridges will receive a CAN message, process it, and then they will send this message at the perfect bit form, or with the perfect bit form. And obviously in environments with electromagnetic noise and interference, this will greatly improve the signal quality on your network. And the last point, specifically for the gateways and bridges, because they have a microprocessor, so they have data processing capability, is doing data processing to your CAN messages. So we just mentioned this with multiplexing and demultiplexing your CAN message, but these are only two examples. You could also switch identifiers, you could also switch the payload, do data manipulation on your payload, do all sorts of things. And what is especially nice with the CAN bridge and CANetNet is that you can even run Lua scripts. So you can write a small Lua script where you specify what you want to do with your payload or with this respective message, and upload it or download it to this gateway and bridge, and then it will execute your Lua script.
Besides bridges, gateways, and interfaces, HMS Networks provides a whole comprehensive series of CAN and CAN-FD repeaters. What are they used for?
So in comparison to what we just discussed, the gateways and bridges, CAN repeaters don't have a microcontroller and thus are more passive components and are far less invasive to your network. So what repeaters will do is basically just a bitwise repeating of every bit they receive. And one of the key differences, or one of the main differences to the bridges and gateways, is that repeaters are a lot quicker. So repeaters will usually have like a cycle time, or a time that it takes them to repeat the CAN signal of 175 nanoseconds. So in terms of use cases for these repeaters, there's typically or usually two things we do with these repeaters. So the first one is just improve the overall signal quality. So think again in factory or a test facility with a lot of EM noise or interference, and you're experiencing error frames on the bus or just in general some trouble, then the repeater will restore a perfect bit form and increase the signal quality. So this is a good option for customers that experience this. Just plugging in a repeater to see if it works without doing more detailed investigation that could take hours and hours and be a lot more expensive than just using a simple repeater. And the second one is the galvanic isolation. And we mentioned this with the bridges and gateways because they are also galvanically isolated, but the repeaters have a higher isolation and thus have a bigger protection, or are made for more use cases to galvanically isolate different bus segments from each other. And now in comparison to the bridges and gateways, some key differences in terms of using them is that the repeaters require no configuration, so they are basically plug and play because they will just do bitwise repeating. And they will transmit error frames in comparison to bridges and gateways that won't transmit error frames. So if you are looking to increase the signal quality in a logging application where you specifically want to receive error frames and log this, you will require to use, or you will need to use, a repeater.
Wow, thank you for your detailed explanation. Do you have any other solution in mind in regards to more specific applications?
Yes, of course. For example, our two very powerful embedded Linux platforms, they are called the Connector or FRC series, and they offer many different interfaces specifically for automotive applications. So for example, they have up to 8 CAN interfaces, out of which 4 are CAN-FD capable, or are able to transmit and receive CAN-FD messages. And these two platforms have the functionality of reading CAN-DB files. So they are also called DBC files, and these are files where the whole communication that's going on within a CAN network is described. And because of this, because of their capability to understand these files, you can do, for example, signal-based mapping. So you can map one CAN signal to another bus, or you can do signal-based logging. But this is a whole topic for itself, and I would strongly recommend you to check out our YouTube channel because we have more videos specifically on this topic.
Thank you for your detailed explanation. Can you elaborate a little bit on what kind of developments that you foresee for CAN and CAN-FD in the future?
Yeah, for sure. So if we look at the CAN and CAN-FD world specifically, there's obviously the big thing now coming up, also under specification, but we're waiting for the final specification, and this is called CAN-XL. So just a quick explanation, CAN-XL is now the next generation of CAN networks with a payload of up to 2048 bytes and a data rate of up to 20 megabit per second. So this will enable even higher data throughput and new use cases such as Ethernet tunneling, for example, now in the CAN world as a use case. And the second thing is not so much CAN and CAN-FD related, but at least in the automotive world, this is also a topic, is automotive Ethernet. So we are really excited about the latest innovations in 100 base T1, 1000 base T1, or also 10 base T1S, which is more the competitor to CAN XL. And either way, we are very excited for these new technologies and innovations, and also look into incorporating them in our future product offering.
For those valuable insights, Christopher, again, thank you. We hope that this expert talk has been informative and clarifies the migration process from CAN to CANFD. If you have any questions, please let us know by emailing us at ixxatwebinars@hmsnetworks.de. Thank you for watching, and have a nice day.